Well, hello. I'm Michael Tomko. I'm the production director here at the Able Few. And I think I'll start this off to say, I think as the few folks in the room who know me pretty well as a developer, I rarely call myself a developer. I'm typically a person who likes to solve hard problems. So I don't have any training as far as development goes in the classical sense. I usually will dive in and try to find a tool to solve the problem that I have. So I may not say all the right words sometimes, but bear with me on that. In the pursuit of solving a really hard problem, which I'll get to a little bit later in this, I stumbled on Lazy.js. I don't think even when I started using it, I knew exactly what lazy evaluation meant. I just knew it was really fast and the thing worked really well. It helped me solve my problem. So I've been pretty passionate about it since then. And now I actually primarily write in Ruby, and now that Ruby 2 has lazy evaluation in it, I'm happy as a clam. But is there anybody in the room who's not familiar with like what MapReduce is, or how to chain methods and iterate over arrays? I mean, has everyone in here anyone used underscore or Lodash? Okay. We'll just go ahead and jump in. So what is lazy evaluation? Well, Wikipedia says in programming language theory, lazy evaluation, a call by need, is an evaluation strategy which delays the evaluation of an expression until its value is needed, and which also avoids repeated evaluations. Well, I figured I'd have to find a way to better explain that. So I'm going to ask my lazy dog Zoe to help us get through this. So we'll set up some stuff here. We're going to create a new dog object named Zoe. We're going to list a couple possible items that she might be interested in. And we're going to list some items here that we don't want her to play with. It's mom's sock, if you can't see it in the back. So she's got her two dragons, which, you know, as you can see, she loves that dragon. So in eager evaluation, which is the standard, we're going to take our array of items and we're going to first chain a method called retrieve_your_toys. Retrieve_your_toys is a map function. It's going to loop through all the possible items, and it's going to update each item.retrieve value to true if it was retrieved, and collect them into a new array. Pretty simple. Well, no, not that, because we don't want Zoe to get mom's sock. So it's going to now make a second loop through the now modified array, and returns a new array of items available where item name is not mom's sock, and item retrieved is true. Now our third function, the drop them function, is a reduce function. It's going to now loop through a third time through the previously filtered array and returns an object containing counts for the number of toys found at each location. Pretty simple, right? Well, let's see what would happen in Lazy.js. So the main difference here is that we are creating a lazy item at the beginning. But the interesting thing is that instead of iterating over the collection at each step, lazy's iteration is controlled by the tail of the chain. Okay? So in this case, possible item, index 0, waits to be called until some function in the chain calls it. It says, okay, hey, we need you. It's time. So what happens is the chain operations are then performed in sequence, and then they increment the object if necessary, all before moving on to the next item. So in the first example, where we looped through each step and did an entire loop through the collection every time, in this case, we're chaining these methods together, and we've done this all in one entire loop, as opposed to 3. And in this case, it's the reduce function that told it to evaluate. Because the reduce function expects an output that's different than a sequence of the original array. Right? In this case, it's an object. We started with an empty object, and it's an object that contains locations. So, sorry, this remote is weird. What this means is that a lazy sequence can be stored and passed around and further chained throughout an application before it is ultimately evaluated by an explicit request for it to do so. Well, here's a couple other examples. So the first two toys attribute, we're going to take mostly our same chain, but in this case we're going to chain on take 2. In this case we're going to say, okay, do this chain and take 2 of them, but we still haven't evaluated it yet. We've just created a sequence. So it stores a sequence object. So if you were to just call Zoe.first 2 toys, you'd get back a sequence. So now if we call toArray, on our saved sequence, we get back the first two elements of our original array, or of our now permutated array. If we were to call each, it would, and console log the name of each toy, we'd get this value. We're only getting 2 instead of 3 since we call take 2 in our chain. Well, I guess that's great that my dog can pick up its toys performantly, but now what? So let's say we want 300 unique random numbers between 1 and 1,000. So in this case, we're going to take advantage of Lazy's generate function, which says, okay, if you don't have a collection that you want to iterate on, you can generate one by saying Lazy.generate. So in this case, you can stash a function inside, return a value, and that value bubbles up to the next link in your chain. Okay, so you didn't originally, there's no array that we're starting from. We're just generating some values. So in this case, what we're doing is we're generating a random number, and then on that next iteration, we are multiplying it by 1,000 and adding 1, right? Now then we are filtering out unique values, and we're going to take 300. Because remember, we wanted to have 300 unique random numbers between 1 and 1,000. So we haven't actually called the iteration yet. In this case, you know, if we said to array, it would put out array. If we did each, it would let us iterate over each value. But the neat thing to realize here, and generators are actually the biggest reason I started using Lazy. What's so cool about this is, in a typical scenario where you might have needed 300 random numbers, right, and to do some sort of loop over them, you would have had to generate an array to do that, right, or some collection in order to iterate over. The problem, though, is we wanted unique numbers, right? So in this case, take 300 being after unique means that we may run this loop 500 times in order to get 300 unique values. So when you have a scenario where you have to ultimately end up with an exact number, this works really well when you have filters in the middle. So that's a pretty simple example. You could do a Fibonacci sequence as a little more extreme example. So here we're storing a generator in the variable Fibonacci, and this is kind of down at the bottom. But what we're doing here is we're saying, okay, we want the first 10 Fibonacci numbers plus 1, meaning take the generated sequence, map it through an incrementer that increments each number by 1, take 10, and output it to an array. And this is what we get. Go ahead.
Back to the Fibonacci's. The function, the generate, returns a function.
Well,
but that wasn't the case in the first one, right? You returned a evaluation of value.
Well, so this is from the it's being called on itself essentially as it goes through. This is from their docs. So I mean, I didn't write this. I don't have a need to write it. But
that function gets called immediately after it's declared. If you look at the closing braces, it's called.
Oh,
so
I'm sorry.
The only reason they're doing that
I missed that.
No,
I got it now.
Yeah. No, but that's a good thank you. So yeah, so I mean, these are two good examples. I mean, the thing is, like, you don't know you need this till you need it. You know, like, I was sitting here trying to dream up all these examples of, other than the problem I'll get to in a minute, of why to use a generator. And truly, it's one of those things where, like, at least in my case, if like you feel like you've exhausted every other resource, you probably need a generator. And it is coming out in ECMAScript 6, not fully adopted yet. The syntax is a little different, and obviously what's coming out is gives you greater function here. But I can't tell you how many times I've tried to write around this and had to generate some initial value that I'm just really I'm going to throw away. So this worked out really well.
So anyone who knows Haskell is going to be highly reminded of it by this. And one of the things that you would do in Haskell to a Fibonacci sequence is you can actually create the sequence in terms of itself by saying it's 1 and then a 1 and then it's a sequence of the sums of its own sequence, like zipping together basically.
Exactly.
Is there any, is that possible in Lazy.js?
You know, it's interesting, and kind of the next part that I wanted to talk about was kind of the difference between it and like some of the other libraries that are somewhat similar. And to answer your question, and I was talking with Michael about this earlier, when I started using Lazy.js, it was at like version 0.014, right? I mean, it was like way in the infancy. And it had a lot of cool features. Some of it was broken, you know, whatever, but it had enough of what I needed. And as it's gone on, he's gotten really almost, in my opinion, a little ahead of himself. Like, created a bunch of different functions that don't all do what you would expect. So to answer your question, throughout the whole library, there's times where you can be using two separate sequences and get on the other end what you want, and there's other times where the results are not at all what you want. So I don't know directly on that question, but it's possible that it works like you'd want it to, and it's possible that it'll be the exact opposite.
I was going to say, it strikes me that you could probably, in the inner function, you could probably refer to Fibonacci and be okay and do some kind of recursive definition. I mean, I don't know because I haven't played with it, but that would probably work. You certainly couldn't do it in the outer function, the one where the bars are declared, because at that point Fibonacci is not anything useful at that point, you know. So because it's big, right. So I mean, there's probably some tricks you can play with the closures and when the function's getting evaluated. Go ahead.
I was going to say, if you happen to have after your generate function here, you happen to have something like take every other one, for instance, then that would break that because it's not going to be smart enough to know that it really should be, it needs to be evaluated, because that function has a side effect, and Lazy won't know that.
Yeah, quite
so
possibly.
That's probably an example, I think, of what you're talking about.
Yeah.
Whereas the past I wouldn't have that.
Are you sure that?
I mean, to be honest, I don't know. You're either right or wrong, and I don't mean in theory. I mean, you know, like sometimes, like it's weird how that.
Oh, you're probably right.
Yeah, I mean, you're probably right, but possibly.
Writing this framework, that's probably how it would work.
If it's just treating the function as like a promise, and just when it's called upon, it calls it, as opposed to as it's iterating, making sure it calls the function. I don't know.
Yeah, I think the side effects is the issue here. I mean, if we were dealing with a language where everything was effectively, immutable and side effect free, I mean, sort of the same thing. But I mean, then that wouldn't necessarily be an issue. But there, I mean, you're actually side affecting those variables to get the right answer, and it's going to get messed up. So.
Right, which is why, like in Haskell, you would do it a different way.
Is there a take every other one?
I mean, you could do. Well, that's a good question.
Could you take
I mean, that's the premise of Nick's question, right?
I mean, well.
What was the question?
Well, is there a take every other? Is there a function for that? I mean, what you could do is store the last value, and use something outside of the chain, or something like that. But what?
You could reduce.
Yeah. Right. Yeah.
Or could you do a filter after the take to filter out every other?
Quite possibly, yeah.
Like take 20 and then filter every other, get 10 and do something.
It's not going to work because it's evaluating it backwards. If it's doing it performantly, it's going to do pulls on each one of those up. If it's not doing it that way, then it defeats the whole purpose of the framework.
Right.
It has to be.
Yeah, I don't know. I mean. Right. Yeah.
Does like I know in Clojure when you're working with lazy sequences that the members of the sequence are cached. So for example, if you were to do take one, you're only going to run the computation the first time. After that, it's just going to hand you the answer back. Does lazy do that as well?
Mm-hmm.
Okay.
Yeah.
I mean that makes sense, but
I mean if you inspect the sequence object, there's a parent, and it has a bunch of junk inside to it's amazing though at the size of your collection. Like if you run like a take 1 to array, it is tremendously faster than iterating over all 10,000 items, for instance. So yeah, it seems to do that. To be honest, I don't know all the internals of how it works on everything. And like I said, I've encountered numerous things where it's maybe contrary to the doc, but like in between little minor versions, things have spun around. But what ultimately got me here, and I don't have a slide for this, so I had a problem that I wanted to solve, and I actually started with underscore. And underscore is a great library. Like it has, I mean, for most cases, like it's perfect. But in my case, my problem was I'm building a Spotify app, and I'll show you in a second here, where essentially the problem in Spotify is that their shuffle sucks. Like it is the worst. My theory is that there's not enough entropy actually in the application because it's using this weird sandbox browser in how it runs the desktop application. So my theory is that there's not enough entropy, or it's not varying enough every time you use it. So you're if you're shuffling the same playlist multiple times, you know, like you load the application again and you shuffle this playlist, you get the same songs over and over. It's absolutely annoying. And also, it doesn't know you've already listened to a song. So like, if you close the app and you open it back, like God forbid it freezes or you got to restart your computer, like you've just restarted your listening to. And so that's a big problem for me because I probably listen to 40 plus hours of music a week just at work. So I started writing Rock Tumbler, and the whole concept, I had to purposefully make it super simple, you know, to not like try to just bloat it with features because it's inside of a music player. So if I want music player functions, I'll use the music player. But so the general concept was what I wanted it to do was to shuffle my playlist, but to also remember the tracks I've already listened to, including if I come back. Where this began to become a real problem, because those are easy things. I mean, it's easy to randomly sort an array. I mean, those things can be solved pretty simple. Where it started to really become a problem, though, was I started to have the same issue with just your standard random sort. It was having it was having the same entropy issue where the shuffle was happening the same way. So the second problem was the way that I listen to music is because I like music so much, I have trouble deciding what to listen to. So I create a playlist for whatever year that I'm in, and I just put all new releases into that playlist, and I only listen to music from the current year. That's just the rule. So the problem is that music's released every Tuesday, and so every week I'm adding a couple hundred songs to this playlist. Well, very quickly, you go from having a 500 song playlist to having a 10,000 song playlist. And from a performance standard, that became, using underscore or using vanilla JavaScript became just impossible. Secondly, I really do want to release this at some point on the app directory for Spotify, and their checklist says that the fans in your computer can't come on. And so that became another problem that I had to solve. So to kind of show you what it does here, so I'll take my 2014 playlist, which you'll see right now has 2,800 tracks. And sorry, this is hard to do over my shoulder, but I just drag it on. Of course it's not going to work or something long. That's something. Their sandbox browser is real weird. What is going on? Sorry.
That or UI?
Yeah, it's the UI. It's the, if I'm going to take the second here to complain about Spotify, so the thing was, a year ago I had this app almost ready to release, and the week prior to, I just started going through the checklist, and the week prior to when I was going to try to release it, they released a whole new version of their API. Completely blew away everything I had just written. Luckily, they still support it. Booting up Spotify is the worst too, though. But it blew away everything. I mean, it went to this whole promise system, which I think ultimately is going to be better, but like it's not a drop, like the whole thing fails in the new API.
And that was the day you became a real programmer.
Right. Thanks, Phil. Oh, come on, Spotify.
They're not using Lazy.js, huh?
You should just re-implement Spotify.
Well, my hope was always, there we go. My hope was always that they would like look at the code for my app and be like really excited about it, because I think it does their job better. Oh, what is happening here? Yeah, find my favorite music. That's what I want. So the other thing I was going to complain about is that they don't. Where is? Oh, there it goes. Okay. They don't let you. If you're using a developer app, they don't let you. You can save it to your favorites, but when you reboot, it loses it. I always forget the path, so hopefully we work now.
Like, do you have to end up using a special version of Spotify to do this, or is
You got to enable your account as a developer,
Oh, okay. But it's not like a separate
and then it gives you the develop thing. No, it's not a special version, no.
to awkwardly type it into the search.
What is happening? I don't know why it won't work. So, okay,
It's like
something's.
seeing it as a, like,
Oh.
clicking on.
You know what I might have done in the process of, you know what? Here, I know what exactly what's going on. I think I borked at making this presentation.
That's kind of good.
Yeah, exactly. There we go. Okay. So, yeah, there we go. So it takes a second on that big of an array. Something I'm still working out, but I mean, on typical people's playlists, I mean, that's even not too long to wait, right, in reality. On typical playlists of like a couple hundred tracks, I mean, it's instantaneous. So it's getting better. So right now, it created, so it set my playlist up to play, and it's showing me my playable tracks right here, which there's 152 hours worth. But of my 2,800 songs, only 2,300 are available to play, because I filtered out tracks that I've already starred, and it knows, as you can see, what I've already done here, what I've already listened to. Which is great, because if I close, you saw me close the app. I mean, it knew that I had it. So, like I said, while this may sound like a simple problem, there's a lot of data here that's in all these objects. And so what I wanted to do was do a distributed random sort, right? I wanted to do something that was still randomized, but it had some weight to it, right? It shuffled things around with some precedence. It helped me bubble up tracks from disparate playlists that might be deep cuts or songs that I might not have otherwise gotten to. And with their shuffle, I wasn't getting out of 100 or 200 songs out of this many. It was insane how often the same stuff would come up. What I did was I auditioned. You know, I started with underscore, and you know, to be honest, it was a great library, but it was not terribly performant in the scheme of things. So then I found Lodash, and Lodash is awesome. Like Lodash was like, it was like night and day getting into that. It was great when I was doing non-distributed random, when I just needed something that could mash arrays around and could sample stuff out of it, or could do a lot of filtering. Like it was awesome. Well, then I got turned on to this concept of doing a roulette wheel genetic algorithm. which is awesome. I mean, like, listening to this is a dream. Like, and I don't mean like just because it remembers what you played. Like so my workflow is to star tracks that I like, right? If I'm listening, I'm working, I'm listening, and I like that, I'll star it, because if I ever just want to listen to music I know I like, I'll just listen to the starred playlist. And right now there's a couple hundred. But if you think about that, there's a couple hundred tracks that I've starred out of thousands in 3.5 months. You know, it's 2.5 months into the year, right? So what's happening is I've created an algorithm for sorting these that ends up kind of bringing out the underdog in a way that I think is actually pulling good songs up above the rest. So the roulette wheel thing, though, is a pretty hard problem to solve in JavaScript especially. And so I'll kind of get into that. Is anybody familiar with the roulette wheel sorting? No? Okay, cool. Okay. Okay, so a roulette wheel sort. So it's a sorting algorithm that allows you to perform fitness proportionate selection of elements based on the genetic makeup of a collection. I know, it's bonkers, right? So we'll just kind of get through it. So you go through a couple steps. First, you loop through all the elements in your collection, and you evaluate each element's fitness for selection. Like how, if you think about the Hunger Games, like how fit are you to select, right? And you group the collection by fitness. Then you generate a roulette wheel array based on the distribution of fitnesses in your collection. One by one, you spin the wheel. You find whatever fitness it lands on, and you randomly select a track, in this case, from the sorted collection. And then when a fitness group runs out of elements, you redistribute your wheel. And then you continue spinning until you've recollected all. So you can imagine this is way more in depth than your typical random shuffle, right? So performance is terrible. So if you think about how long it took to load 3,000 tracks, but it did all this. So a lot is happening, and it's something improving all the time. So here's a visual representation. It's a little squeezed, but here's the concept. So here's 5 different fitness groups, and they're broken out on your roulette wheel. So the concept here is that, and I'll bounce back between. So what you do is for each element, you generate a chromosome. Okay? You generate that by saying, okay, if you think of each one of these bits as a true or false, right? So in the case of songs, and I'll show you in the code kind of what I'm doing, actually, a lot going on here, but here is where it's generating all my bits. So it's doing things like the time the track was added to the playlist. So was that longer than 2 weeks, 1 week ago? Was it longer than 2 weeks ago? The popularity value on Spotify, is it less than or equal to 25? Is the duration of the track greater than or equal to the average song length by decade, which, yes, I did figure that stuff out. Is it less than or equal to, right? Let's see. I came up with significant track numbers. Historically, right, when there's all these things that in the world we all still do, even though they're antiquated. Like every press release still has 3 pound signs at the bottom, because that's what used to tell the telegram to stop, right? But you get an email with 3 pound signs at the bottom. Well, in music, on vinyl records, sonically things sound better on the outer part of the record. That's why your singles are typically tracks 1, 2, 4, 5, or 6, you know, and on. Those would be the front of each side, right? So the funny thing is those conventions have still carried on. So that's one of my things. Let's see. Stuff with popularity: is the track starred? Is it in the top list, US top list, global top list? I'm getting into doing some things with if it's on your friend's top list, stuff like that. So right now, this is where the algorithm stands. This is what I generate. So that's how I generate these chromosomes. Basically, you just make a string of 1s and 0s, right? And you front weight them. So you do them from right to left. Because when you then convert this to an integer, the ones on the right are weighted higher than the ones on the left, right? So what's really neat here is you can fine-tune your algorithm by just simply moving these bits around. And you have to play with it a bunch to see how the sort's going to work. Right here?
Yeah, I was going to ask if that two binary, all those lines, that's kind of in order of...
Yeah, it's absolutely in order of priority. And this is where I get to program it for me. Like, I get to start saying, like, what are the things that begin to make a difference for me? So something as simple as, like, was it added less than a week ago to my playlist? To me, that was a big one. And the cool thing about these is these are things I can put into the UI as toggles. So I could say, like, oh, well, this isn't important to you, like, and let you weight your own. But I've still controlled the importance factor. And the neat thing is, if some of these are really rare, where they'd be truthy, that makes a track jump way higher. But if they're really common, it's like a no-net game, which is beautiful. So, for instance, if you were to throw in an album or like one artist's whole collection of tracks, it would still sort it with weighting, although it's going to be more minor changes.
So I love EAs, that's what I've done a lot. What's really cool is it's called basically meta evolution algorithms, and you can basically tweak all those parameters and tweak the ordering also with the EA.
Right. Yeah.
So, do you have an idea of how many songs come out each week? It's probably a ridiculous problem to have happen in like your client, but I was just wondering if this is something that's even feasible on. You could have, say, a server running somewhere that does the same sort of operations, but just delivers your playlist to you.
And you certainly could. Like, you could get into this for recommendation engine stuff too.
Yeah.
The problem with release week stuff, so it depends on where you look. Like, I have kind of a process every week that I go through where I go to some curated locations and pull, and manually put the stuff into my playlist. Yes, I wanted to just build a scraper. I'll get around to it, where it scrapes those curated locations. But if you go to Amazon, or you go to iTunes, for instance, God, the crap you're going to wade through is terrible. So in my case, it's already somewhat pre-curated, and then it curates itself. But yes, these random country records get in there that like somehow meet the criteria.
And I imagine it would start off terrible and maybe be permanently terrible.
Yeah, I mean, this doesn't fix your taste. Like, if you have bad taste, you're just going to get bad taste sorted really well, right? So anyway, what you do then in JavaScript here is so you create a string, your binary string, and it can be any length you want, and then you take that and parse it base 2. Right? ParseInt base 2 converts that binary string into an integer for you. And you mentioned the two binary thing. So in the fact that Spotify's max playlist length is 10,000. So like 2013, I was at 6 or 7 or 8 or 9 playlists for 2013. So 10,000 was kind of like was my bench. Like, I want it to be performant at 10,000. I don't care what it's like at 1,000 or whatever. And doing a dispatch table that was literally like it's just an object where the key is true and the key is false, and they return a 1 as a string or a 0 as a string, shaved so many milliseconds off versus doing any other method of that same conversion. And so it seems silly if you're not in it and you know the performance reason, but that's where that's coming from. But yeah, so var b is just saving the parseInt version of my chromosome. So then what you do, yes?
It's actually faster to do what you're doing there, calling that two binary function each time and adding it together, than doing like vector math on that. And then just
this is the best I know how to do at the moment. So of everything I've tried, this is the fastest.
That does look right itself for a map reduce, like because of the this.binary thing, you could make a map and then you could reduce it with plus. I mean, you could wrap plus in a function. So
But there's I mean, and I tried some of that. I mean, like, it's weird, and the thing is, like, there's so many steps in this that, like, if I make a couple optimizations, who knows which one it was. But for right now, the dispatch table is working really well. I mean, it's reusing the same hash every time, so it's been working all right.
I predict you're going to get a few ideas from me.
Yeah. I figured as much. So then what you do, so you take chromosome. Oh yeah, sorry.
This is just a general thing. There was a recent blog post from the guy who wrote shuffling the song from Spotify. I don't know, did you get a chance to read through it? He went through detailed analysis of how hard is it to shuffle a song. You know, like he talked about genetic algorithms and other things and stuff. I didn't mean to put you down. I just wanted to, you know, just throw you out and say if you had a chance to look at it.
I had it, and I think I heard something about it. Like I said, like a year ago, I kind of put this down.
Sure.
You know, like it works for me. Like I use it all week, every day. And I've been meaning to like get back in and try to re-optimize things and get it ready for the new API. But
it was the reason February 28th.
Okay. Yeah, then I actually totally missed that. But you know, like the same problem exists on Spotify on the phone, and like I mean so that's what led me to think it was something to do with an entropy thing that they're you know seeding the random. But so. Your next step, once you've got all your chromosomes and you convert them to an integer, is you generate your fitness, right? So this is your fitness calculation here, which you can see is happening down here. So it's zipping, it's essentially returning an array with your track and its fitness from this function here. But the cool thing is in Lazy, I mean, I still haven't evaluated yet. So I've just stored the map. Which I'll later change and do some other things with. And I've taken some liberties. I'm showing some, like, there's other things going on, and so just wanted to kind of show you some things here. So, so you generate your fitness, and then what you do is you take the sum of the fitnesses, and you determine what percentage that is out of 100, and that's how you generate your wheel. So the difference between what I'm doing, and I think what at least all like the examples of this was that I may end up with 5 or 6 different fitnesses out of 10,000 songs. So I have 5 fitnesses maybe, but you know, one group might have 1,000, one group might have 200. Like it's not proportionally broken up. So I still do it based on the unique fitnesses and their sum, and that's how I generate my roulette wheel. So. This is not proportionate to the size of my collection, if that makes any sense. This is proportionate to the fitness for selection. Yeah.
Where does that fitness function come from, the negative 1/4 x squared?
It's what I found and I didn't question it. I mean, to be frank, it doesn't matter. Like this number doesn't really matter at the end of the day because I could use this number. Like, I really just need a number. Like I need something to call this group.
Some function.
To be honest, I have no idea where it came from. Maybe it has some reasoning. Maybe this whole deck of cards falls down if I don't do that, right? I don't know.
I should try.
Because maybe that's a step I can lose, right? But yeah, so it ultimately doesn't really mean anything. They're just no.
And then also
just
in
a
your
little
code.
background, I worked across the desk from Mike for over a year, and week after week he was producing amazing shit, and he never had really a clue how he was doing it.
Thanks.
Could you go to your code? It might have been missing the negative.
The negative, yeah. I realized that today, and I feel like that was either like.
So maybe
I hadn't
really
looked at this in a while. Yeah, I hadn't looked at this in a while, and I was feeling like maybe it was slightly deliberate or something. Like, and I don't remember what. Like, there was no comment, and like I don't know. So I left it out, and it might have been, if I was thinking back, it might have just simply been that I didn't like what the number looked like when it was done. Like, it just. I don't know. It was weird. Like, because I think it greatly reduces the number. So So anyway, so you generate your fitness, you sum them, and that's how you get your percentage of the total. So from there, I'm just showing you kind of some greatest hits just to show some things out. So in this case, I create my roulette wheel simply by, basically it's a 100 item array full of fitnesses. So if one fitness is 38%, it has 38 representations in the array, right? I mean, it's that simple. So for every fitness, it loads it up. And then simply I'm shuffling the tracks so that when they're put in their fitness group, they're random by that point. And then just loading them into a sorted, like a grouped by hash so that I can call just a fitness and get a track back.
And that's Lazy's shuffle function?
Yes, yeah, so all this, so, you know, and since things are kind of out of, I'm just grabbing some pieces of the app. Playable tracks is a lazy object up there. So because the tracks have actually already been filtered by what has been played and things like that. So when I do any of these iterations, it's not over tracks that I've already listened to or tracks that I'm filtering out for some other reason. So you know, this might have been just an error in copying it over that I call lazy again here because it's already lazy. But yeah, it's a lazy function for shuffle, and I'm using lazy again to reduce the fitnesses in order to generate the object that this starts with, right? Just because it seemed cleaner than having a call to see if there's already an array in a key that may or may not exist, stuff like that. So then I get down to sorting it, and this is where Lazy made this totally possible. So the generator is actually where I spin my roulette wheel, because this was that problem I was talking about earlier, where I have 10,000 tracks I want to iterate over, but I need a roulette wheel value for every one. Like the roulette wheel is what should be starting my iteration, and I'm mutating my tracks. So in this case, the generator allowed me to spin the roulette wheel and pass that value, the fitness value, to my map function. Which, you know, all the different times I tried this with Lodash or whatever, I mean, I had so much mangled code everywhere trying to maintain all these different objects and iterate over the tracks. There was also at one point, and it might have been due to like how early Lazy was, how early of a version it was when I started using it. Sometimes it just threw a false, like it just threw like something broken. And so I originally was having to compact the array before I got out. And so that was another problem with it. So that's kind of where I started. But the other thing is, you know, and so that's where like I wanted to be able to say, okay, spin this enough times to give me 10,000 tracks. So yeah, it's pretty simple. It spins the roulette wheel, provides a fitness value, which comes here. I just basically use the key and pop the last one out of the array. It's already random in that array. And then if that fitness is now exhausted, I clean the roulette wheel out. Now, classically, you would redistribute the wheel to be 100% again, 100 items. Performance-wise, that just doesn't fly. So it still stays at a proportionate percentage, but the wheel gets smaller as you exhaust some of the groups. And then simply I take as many as I need, and then there's some other functions that go on from there to get it set up in Spotify. But I mean, that's the gist of what it's doing, and that's kind of all I had prepared. So I'd love questions or... No, you first.
Are you using async in your lazy chain?
Well, so...
Because that might speed up that initial load where you were waiting.
Yeah, so Lazy didn't have the async option when I first wrote this. They do now.
Doesn't it?
So that's been on my list of things to evaluate. Yeah, I mean, there's and actually, one of the other part of the load isn't all on me. The load right now is the synchronous load of all. I'm going against medical advice by loading all the tracks. Like, they basically say, don't ever call playlist.tracks. Don't ever do it. And that's all I want. But supposedly in the new API, like I played a little bit with the Spotify API that's out now, and it does promises to return those tracks to you. And so like I already got to start the asynchronous approach throughout. So the load will be a lot different when it's on the new API. That loads mostly loading the tracks.
Yeah, because the user's going to see like a few hundred in the first second, and
Right.
they're not going to notice like the 10,000 that are
Right.
still.
Now the interesting thing though is that playlist where you're seeing the tracks is actually their UI. So like you send a playlist to their UI builder and it does it. So I don't know that would be the case. Like I'd have to still wait till I had my playlist in order to set it as the context for their UI element. Which is weird.
If you focus just the first few. And
I don't have control. Like
you might be slamming their context a lot.
no, so like that's what's kind of weird. So I've also thought about rolling my own table of like, or just like showing you the next 10. Like you don't need to see them all.
Yeah.
Their old docs used to say they wanted you to use all their UI elements, and I don't mean design elements. I mean they have functions that you have to call to generate that table, because there's a bunch of actions in there like starring capability and different things in that table. So right now you have to have a playlist completely ready and you set the context of your UI element. It's really strange. So I think in my next version I'm going to skirt the rules a little bit and just simply do like here's upcoming songs and here's a couple of them.
Could you back up the slide? Does it say, so when you get that playable tracks.length, I mean, maybe this is what you're just talking about, and I apologize for making me repeat, but I mean, effectively right there, you're forcing some calculation to greedily evaluate, right? I mean, because that playable tracks.length is itself
No, and you're right. And so,
No, it's still asynchronous. It's still
at the point, at this,
but that evaluates
Immediately, that's a greedy
no,
evaluation.
right. But so this doesn't have any,
right.
yeah, so to my understanding, because this still functions, right? And like I was telling you earlier about like that it used to be that you could call length on a sequence where you had done filtering, where you would have effectively reduced the count of the original array. This has not been reduced. Like what this sequence that this is calling on is, and like I said, I'm showing a bunch of stuff in context here, and I adjusted a little of the code to make it for presentation. So in this case, it's calling a sequence that it's just grabbing, it has this value.
Yeah, that's probably an array-like sequence.
Yeah,
Which is going to be able to return you the length immediately.
Yeah. But you were right. If it had gone through other permutations, it would be wanting to execute those. And now Lazy.js, the current version, fails on that. Like it makes you explicitly call to array on something that's been filtered already, just to get around that misconception.
Right, and that was part of what you were talking about right before I asked my question about, not building the entire list up, but only showing so much of it. I mean, that seems like maybe that potentially plays into that as well, or something like that. I mean,
certainly,
like not having all the playable tracks already pre-calculated.
Yeah, I mean, and like if I was rolling my own UI and doing things like that, like, because part of the other problem is not just what you see, but what you play. And so like, I could go a route of writing like a whole Spotify player that like asynchronously can be generating songs and sending them to the player. The problem though in Spotify is context is everything. And I mean, at least that's what they refer to. So this player has a context, and it's this collection. So if you don't have, well, it's this playlist object. So you take tracks and you generate a playlist. So I could ostensibly create an empty playlist and be running their methods to add, but the overhead of that is way more than just generating it and creating it. And I took a bunch of those routes trying to make it faster and cleaner. And what's funny is I actually have an autoplay toggle for autoplay, the auto toggle there, because sometimes it freaks out like it wants to start playing the song, like, and it hasn't loaded it, like, and it just freaks out. So I do a thing where it recognizes that the player started and immediately stops it. So this time it let it get a second. But you know, a lot of what I'm doing here is like in spite of Spotify. Like, for instance, like they have shuffle and they have a repeat function, and it detects that you've turned those on and immediately turns them off. So like, right, like having their shuffle on, like, or like, you know, I built all these listeners for if you add to the playlist. So it actually handles, like, you could add to your original playlist and it will deal with that. But it's weird if there's sometimes, like, if you like play another song and then you then start playing a song that is also on this playlist, but you didn't play it from this playlist, it just starts deleting track, like it starts doing a bunch of weird stuff. So the context is everything in Spotify.
So they have their own event system? I mean, as far as like when you said handlers, you mean like
Yeah.
they give you a list of
Yeah,
events?
they have a bunch of handlers that you can, you know, that you can observe.
You ended up using Lazy and Lodash in conjunction, or did you just switch to Lazy?
That's a good question. So I think in what's when this was broken a second ago, I just undid all the. I just rolled back in Git. I think that the version that I've been currently using is using both, because there were functions that Lodash just did so well that were not in Lazy at the time. One of which is like a group by function, and I just don't know if like I somehow had some weird in-between version or something, but Lazy returned this like really bizarre nested array thing. Like it was really screwed up, like it didn't make any sense. And Lodash does exactly what you'd expect, which is an object, and each key is the thing you grouped by, and the value is an array of the values. It just, that makes sense to me. Maybe I'm wrong. But so yeah, so I've been using them slightly in conjunction. There's a couple Lodash features, like both of them have string operations, which is pretty cool if you want to operate on a string versus an array. But Lodash has a lot of other just helpers. Like it has a random number generator. It has a times function. So like you can, like in Ruby, you would say like 3 times do, right? In Lodash, you can do like times, you know, Lodash the dash or the underscore times 3 and do something 3 times, and it's when you don't care what's bubbling up from that. You just want a loop to happen in a certain cadence. Lazy doesn't have those. Lazy has like a repeat function, but that's still different in theory.
Times sounds like basically it's very similar to a generator in a lot of sense. I mean,
in a lot of ways,
that's what I mean.
It's a generator. Well, sort of. You could do it with a range. Like, it's one of those things though. The trouble with some of these functions is if you use a range to generate a 3-item iterator. I mean, that's essentially what you could do with that. It's not as explicit. Like if I go and look at that, I'm bubbling a value in my chain with the. And I'm not saying it's right or wrong. I'm just saying like when you look at it, like 3 times do makes sense. Like I want to do something 3 times, whereas a range of 0, 1, and 2 doesn't make as much sense.
I was going to say, you're going to cause side effects too. It seems like the times then makes that more. The generator's times.
Right, but it's like a generator with no function in it. Or I guess, I mean, in Lodash it lets you just simply give it a number and a function to run, and it runs it that many times. So there's a bunch of little things. I'm kind of in the process of trying to strip those out just simply for the sake of loading 2 libraries. The cool thing though is in Spotify, like it's all local. These are all like all the library, like it's not making any HTTP requests for any of the libraries. So I haven't cared much about loading stuff. Another thing I've tried recently was Parallel.js, which is a web worker library. That's pretty cool, and they have MapReduce amongst web workers, which when I heard that I was like, oh dude, that's so cool. I'll distribute this amongst 4 threads and it's going to get done so fast. And instead what happens is it like, say you need a library or something to do, like it makes an HTTP request for every element in your collection. So like it very quickly becomes something you don't want to use. But yeah.
I was just gonna mention I have a repo up on GitHub that has a number of V8 performance tests that do things like comparing map and just basic iteration. And one of the things that you can see with the numbers there is like map or any kind of function where you pass a function to it. It has a good way V8 works, but basically it ends up atrociously slow because it's polymorphically selecting the function. What I was wondering is if you compared any of these things in cases where it does have to evaluate it, if you compared it to the basic built-in map to see if it's more performant or less?
I have not, only simply because I have always needed something else to happen. You know, like everything's changed in what I'm doing, but no, I haven't compared. I haven't spent too much time with it other than, you know, having these same chains set up in Lodash and in, well, first Lodash blew underscore out of the water, and then Lazy just seemed to just dominate. Even if I used it wrong, like even if I called to array all over the place and stuff, like it was still way faster.
It seems like all the performance gains here are going to be gained by the fact that you're really stacking up computations. You're not just chaining them together. It's not like you're just making a pipe and pushing a bunch of stuff through it. I mean, you're actually delaying that computation until you really need it.
Yeah, because I mean, in this case, and it sort of mirrors a lot of what I do in Ruby, where I may have something that I need to chain late. You know, I've got this part of the chain done. Like I built a Tumblr client this week, and like I had a situation where I needed to, depending on user options, change how all these posts were sorted. Like it goes out and it gets a month worth of posts and it displays them and it does stuff. And so I needed to change how things were sorted. So I was able to save the sequence and programmatically chain different sorting options, you know, which is really nice. Which I wasn't able to do which I was able to do, but not defer the evaluation, you know. So yeah, that's the biggest performance gain for me, is I can do all these programmatic things to determine what the change should be and then evaluate it instead of every time, you know, doing 2 loops here, 3 loops here. But yeah, and some of the way these things are stacked too was in Lodash it made more sense to stack some computation in a loop. You know, as many things as I could get done in this iteration, because otherwise it's, you know, it didn't make sense to chain more things, or at least how it came out. So.
Now, all your code is up on GitHub, right? So we could look at this.
This is up on GitHub. Yeah, the nerd sort branch is where the weirds, this is all happening. Before that, I was using different versions of kind of a random shuffle, which works. It's fine. I mean, you still get the remove tracks, so you don't have the same problem. It just wasn't. Like, I honestly personally feel like I've tweaked this thing to the point where I really like what it plays me. Like and when I listen to this same playlist on my phone on shuffle, which is just Spotify's regular shuffle, like I just don't hear anything I want to hear. I mean, usually, or it's a couple songs and then it's a bunch of junk for a while. So I don't know. Maybe I'm onto something. Maybe I'm not. But, I don't know if anybody else has this same problem. Because I've always wondered if it's like a...
We've done some stuff with that type of sorting that you're talking about there, and...
I just meant the song thing. Like,
Is this one of those first world problems that you have?
To some level, yeah. I mean, my problem prior to that was that the song I was listening to in my car that I wasn't done with, I couldn't pick up right where I left off. That was actually a planned feature. Was a way to sync between the two, but eventually I'm gonna. I've got the bare bones set up of just a API server running locally, to where right now I'm using local storage, which to save, you know, like what you've listened to before. And what's happened in later updates of Spotify is that now gets for some reason cleared on a restart of the computer, which is annoying. It used to just be fine. Yeah, right. But I believe in my tests, like IndexedDB works. Like it's not cleared. so I was going to switch that and stuff. But I was setting up an API server to actually just get that out of local storage and have a place to send it, and eventually I'll put that up on the web, and maybe you'll have an account at Rock Tumblr.
Yeah.
Cool. Any other questions?
Can we play something off For the Baby?
I'm having a baby in July, so I mostly put that there because my wife yelled at me for not having started making a baby playlist yet. So now what I do to torture, I've filled it with songs, and I literally just hold my phone to her stomach when she's trying to go to sleep, and I'm like, no, the baby wants to hear one more, you know.
Eventually there will be at least 2 people in the world with the problem.
There will be. Yeah, for the Baby, I think, has like a bunch of Chicago on it and stuff, and like ska music. So, yeah. I mean, do you really want to hear stuff from this place?
Now, is your wife using these algorithms?
No, I don't think she grasped the concept. But I do have a couple mostly non-tech, certainly non-developer friends who I've had testing it, and they're just normal people who use it at their office, and the response has been pretty cool, because it's one of those things that you maybe don't notice the friction of this problem until you've gotten rid of it. And once you've gotten rid of it, you're like, holy crap. Because now if I'm without this app, I'd have trouble. I don't know what to do. If I'm on my phone, I don't know what I want to. That's why I have a starred playlist, because I've already vetted that. So
maybe this is what you were talking about with the whole API server. I'm not familiar with
Yeah.
Spotify does this, but is there a way for you to put this process on a server somewhere, generate static versions of these playlists, and then ship them out to your individual devices?
Well, there is, and one thing that I could do, and I would have to do this just at a minimum, when I'm talking about the API for Spotify, it's a JavaScript API that, I'm not making calls out. When I use JavaScript in their app, these objects are just available to me. And their public API is bullshit. You can't even deal with playlists as far as the public API is concerned. But what I could do is shuffle a playlist and save it as a new playlist under my user, and then listen to that pre-shuffled on my phone if I wanted to. So I could make a portable button or something, take this with you. But
yeah, years ago I used to do something similar with iTunes, where I wanted to craft a randomized playlist, but then preserve that specific playlist and keep it in iTunes, so that, for example, I would do these 600 song playlists, which I know is nothing for what you're doing, but I would do them for trips, and I wanted to make sure that during the trip I didn't have to hear the same song over and over again. So I would randomly create a shuffle playlist and then only use that playlist for the trip. But it required saving a static copy of the
yeah, and I mean that's what this. I mean I've thought of I've even looked into using. I mean I don't know how to make an iOS app, but I played with Ruby Motion a little bit to maybe build one. Making a Spotify client that just shuffles playlists shouldn't be that hard, but that's exactly the whole point of this, is you don't want to hear the same songs again. And typically with most apps, when you start over, when you reload it and you reload that play, you're starting from scratch. So yeah, you could kind of save it and kind of hopefully know where you left off or whatever, but I could make one for you to save. An API server is just simply going to give a place for you to save your play, to save what you've listened to, so that the next time it loads up, it knows where to go. But the cool thing is, the next time it loads up, it shuffles again. So you have a newly distributed roulette wheel. If I've already taken 600 tracks out, then it's going to shuffle differently every time you load, but still similar. Which is kind of neat. So, cool. Thanks, everybody.